Hello, welcome to a series of IB Physics videos. In today's video, we will be introducing the very first chapter of the IB Physics course, Unit A.1 Kinematics and Projectile Motion. In today's video, we're going to be covering basic formulas and we're going to be covering, most importantly, the concepts, the things that you will need to learn in order to excel in IB Physics and achieve that 7. Now, in our very first lesson, our IB physics teacher taught us the distinction between a displacement and distance. So, displacement, often denoted as S, is simply the net change in your position. So, for instance, let's say you're at point A and then this is point B, right? If you'd say you'd go from point A to point A, and let's say that they have a distance of 10 meters, but you don't stop there. You then go back to, say, to the midpoint, which is at 5 meters, from here to here. Let's call this point C. So if your movement is from A to B, then to C, your distance, well, what will your distance be? Your distance will be the total distance you've traveled, and that makes 10 meters plus 5 meters. So that makes, let me just denote here as 5 meters as well. So your total distance is going to be 15 meters. But your total displacement, your displacement is going to be simply the net change in your position. So it's going to be from point A to point C. What was my net change? Well, my net change was only 5 meters. I only moved 5 meters to the right. And as well as it's important to denote that your displacement can be a negative too. So for instance, if you take this a positive direction, and if you take this the negative direction, the negative direction, and let's say you come to this point B, which is 3 meters from point A, your displacement is going to be negative 3 meters. Displacement from here to here is going to be negative 3 meters. Alright, now that we know what displacement and distance are, let's go ahead and derive out kinematics equation, which basically describe motion. So now let's start off from the very fundamental equation, and that is the equation that relates speed, velocity, and time. So displacement, which in this sense you can interchange it with distance for now, is going to be equal to velocity multiplied by time. Okay, now let's go ahead and write down the equation for acceleration. Acceleration is basically the change in speed, change in velocity with regards to time. So we're going to write down A is equal to final velocity minus the initial velocity, which we're going to denote it as u, divided by time. Or if you're studying calculus, you can write it as dv over dt. Okay, now from this, we can simply use algebraic manipulation to come up with the equation that is in your formula booklet. And so it's going to be AT is equal to V minus U, and if you add U to that other side, it's going to be U plus AT is equal to V. Okay, so now let's go ahead and write down the second equation in our chapter. And that is for displacement. So displacement, we discussed that displacement is simply, it's going to be the velocity multiplied by times, right? And so what we can do here, if we have acceleration going on, we can find the average velocity, and we're going to do that by v plus u divided by 2, and we're going to multiply it by time. And so this is simply an expression for average velocity, and this is time. So velocity times time, this is our second equation. Alright, for the next equation, we're going to go ahead and draw a simple graph, a velocity versus time graph. Here we have our velocity, and suppose we start off from some velocity called u. This is our initial velocity. And then we have a uniform acceleration, which actually increases our velocity at a constant rate. And suppose we stop at time t. Now, what will be my displacement? My displacement, as we said, displacement is essentially velocity multiplied by time. And from this graph, we can deduce that that will be the area of this region. It looks like a trapezium. It is a trapezium actually. So now we're going to go ahead and compute the area of this shape, and we're going to get displacement, because the area is essentially going to be v multiplied by t. So we're going to go and make it simple. We're going to have two areas. The first one is going to be a rectangle, and so we're going to label this area 1, and this triangle we're going to label this area 2. And by the way, we're going to have our final velocity. We're going to just call it v. So let's go ahead and compute area 1. Area 1 is simply u times t. So area 1 is u times t. Now area 2 is going to be, it's a triangle. This difference is, this height right over here is v minus u, and the base is t, and the area of a triangle is 1/2 of base multiplied by height. So it's going to be 1/2 t times v minus u. And the total area is just going to be the sum of these areas. V minus u, as we recall from the acceleration formula, acceleration is v minus u over t. And so we can deduce from here that v minus u is actually at from here. So this is going to be 1/2. Since this right over here is at, it's going to be 1/2 at squared, right? So let's go ahead and write. So the two areas, if we sum them up, it is going to give us the displacement. So displacement is going to be ut plus 1/2 at squared. And this right over here is one of the most important formulas that we're going to use in the IB physics course. Now we're going to derive the last kinematics equation, and that will be simply by replacing the t here with the t in here. So we know that acceleration is v minus u over t, and so we're going to call t is going to be v minus u over a. And if we replace this t with this t right over here, it is going to be quite a long algebraic operation for you to do, so I'm just going to get right into it. If you go ahead, I'm going to leave this part to you. Replace the t in here with this t, and then you should be ending up with something like this. You're going to get v squared is equal to u squared plus 2as. This is our last kinematics equation that we're going to be using in this course. Alright, now let's go ahead and solve a sample problem. Suppose that we have a truck that is initially moving at a speed of 5 meters per second. And the truck's final speed is 25 meters per second. And it's being said that the truck is accelerating constantly at the rate of 2 meters per second squared. Now we have to find the distance, the displacement that the truck traveled during this motion. So let's go ahead. So you're given these three, and now you have to think which formula should you use in this situation. I'd go for the one where v squared is equal to u squared plus 2as, because it has three of my givens and it has one of my not givens. So we're just trying to find the s here. Let's go ahead and plug this in. 25 squared is going to be 625. And then u squared, which is 5, 25, plus 2 times acceleration 2, which is 4s. Here we have then 600 4s. We have 2 over here, 300 over here, and then we have s is equal to 150 meters. So given these three parameters, our truck would have traveled 150 meters during this motion.